In this video, I want to take a look at how we can use some basic identities to verify other identities. And by verify, it's sort of like another word for proving. Someone has stated that, hey, I think that this trig expression is equal to that trig expression, and I need to prove that yes, it is, or no, it isn't. So here we go. I want to show, for instance, I'm just going to grab, 3-4 examples here and walk you through how we do this. I want to show that the tangent of theta divided by the secant of theta is equal to the sine of theta. Now, I have to be really careful here. I'm going to put a little question mark over that equal sign. I don't know that they're equal to each other. I'm trying to show that they're equal to each other. So I need to be careful that I don't treat this like an equation. I know that if I have two things that are equal to each other and I do the same things to them, then the results will be equal. However, it's also possible to start with two things that aren't equal to each other and do the same thing to them and end up with equal answers. For instance, 3 is not equal to 2, but if I multiply them both by 0, then 3 does not equal 2, but 3 times 0 is equal to 2 times 0. So, boy, that just looks ugly. So I need to be real careful that I don't just think that I can do the same thing to both sides and that's going to be worth something. I can't, because I don't know that they're already equal. Okay, so I've got to avoid trying to do stuff like that. So for instance, you might be tempted to say, well, multiply both sides by secant. It's like, no, I don't want to do that. What I want to do is I want to take the left-hand side, see if I can make it look like the right-hand side. Or maybe take the right-hand side, see if I can make it look like the left. But I never want to cross over. There are times when you can make the argument that it's legal to cross over. But for the most part, if we can avoid it, it's probably better for now. So what I'm going to do is just see if I can... generally, I look at the more complicated side and say, well, can I simplify that to be the simpler side? Well, let's see. This is a sine. This is tangents and secants. I'm thinking, well, maybe if I convert tangents and secants into sines and cosines, that's always my fallback position anyway. Can you turn it into sines and cosines? Yeah, I can. Tangent of theta on the top there is the sine theta divided by the cosine theta. The denominator, secant theta? Sure. That's 1 over the cosine theta, right? Reciprocal identity. So I've used a quotient identity on the numerator there and a reciprocal identity in the denominator. And then I say, well, heck, I know how to divide fractions. I'm going to take the top fraction as it is and multiply by the reciprocal of the denominator. And what I have is a product of two things here. I've got a factor of cosine on the top and a factor of cosine on the bottom, right? I'm saying factor because things are multiplied together. And with a factor on the top and the bottom, I can say, I don't need to do either. That and that are going to cancel out. And what am I left with? I'm left with the sine of theta, which indeed is equal to the thing that's over on that side. So I've shown that the left-hand side is equal to the right-hand side. Never did I cross over and do some things that way. All right, stayed on one side. All right, let's go for another example. How about something a little more interesting here? Well, I don't know if it's more interesting or less interesting, but here we go. E.g., how about this one? Sine squared theta over cosine theta equals, boy, that's annoying, equals secant theta minus cosine theta. Got a new game the other day that I've been playing, and it keeps giving me these notifications. It's like, I don't need the notifications, and I don't know how to turn them off. So anyway, hopefully that won't become too annoying. Here we go. Is this left-hand side equal to the right-hand side? This is interesting. This is a quotient of a couple things. This is a difference of a couple things. They look completely different, and yet somehow they're the same. Well, I'm looking at this saying, well, am I going to take the left-hand side, turn it into the right-hand side, or vice versa? I actually think I want to work on the right-hand side on this one. this is sines and cosines. This is secants and cosines. Like, secant. Let me try turning that into, what is this, 1 over the cosine theta? And I've got minus the cosine theta. Well, this is, maybe I can take these two things, think of them as a sum of two fractions or a difference of two fractions, combine them into one fraction, because that's all I have over here is one fraction. So I'm always, what are the things I can do? There's lots of things I can do. There's not one way to do this. But I'm always, when I'm verifying an identity, I've got a goal in mind. I'm working on this side, trying to make it look like that side. What are the differences? Well, yeah, I got to somehow get these into one fraction. So get a common denominator. I'm thinking of it like this. So the common denominator is just cosine theta. So I can leave that one alone. And I'm going to take this fraction here, cosine theta over 1, and multiply it top and bottom by the same thing, being the denominator that I want. Okay. Then this turns into, I've got a common denominator of cosine theta. The numerator from here is 1. The numerator from here is cosine squared theta. And I look at that and I say, how am I doing here? Well, the denominator is the same. Is the numerator the same? Okay. And here's where the more familiarity you have with the identities, the better off you are here. There's a Pythagorean identity that the way I first remember it is that sine squared theta plus cosine squared theta, come on now, cosine squared theta equals 1. But if I were to rewrite this, just do a little algebra on this, and move the cosine squared to the other side, subtract it off, I'd have that the sine squared theta equals, that's the sine squared theta equals 1 minus the cosine squared theta. So I'm looking at this numerator here, this cosine squared theta, and I'm thinking, well, I can just replace that with a sine squared theta. Oh, and it's not a cosine squared, it's just a cosine on the bottom, right? So I used a reciprocal identity here. I used a little bit of algebra to just, how do you add fractions. Then I recognized a Pythagorean identity to turn that numerator into this one, and this is equal to what I hoped it would be. Okay. Let's see, I want to do another one. How about this one? This one's a little more involved, but it's got a little bit different flavor to it. I want to do the cosine of theta plus 1 over the tangent squared theta equals cosine theta over secant squared theta minus 1. And I'll put a question mark over this. I need to verify it. I'm claiming they're equal to each other, but I don't know. So what I'm going to do, what am I going to do? I'm looking at this thing, it's just one fraction either way. It's got, I'm looking at those thinking, hey, there's a relationship, isn't there, between tangent squareds and secant squareds? I think it's 1 plus the tangent squared theta equals the secant squared theta. Oh, yeah, and all of a sudden I'm feeling really bad because this is not the statement of the problem. So the problem is this didn't have a secant squared in it. That just had a secant. So sorry, I wrote that down wrong. This is just a secant theta. Now, what am I going to do? On this one, I think what I'm going to do is I'm going to go to my old fallback position of just switching to sines and cosines. And I'm going to do it on both sides. So I'm going to work with one side for a while, and then I'm going to come back and work with the other side for a while and see what happens. So for instance, I'm going to work with this side. The numerator is just that. The tangent squared theta on the bottom is sine squared theta over cosine squared theta. That's my quotient identity. And now I know how to divide by a fraction. I'm going to multiply by the reciprocal. So I've got that cosine theta plus 1. That's already on the top. And that's kind of over 1. And then I'm multiplying by cosine squared theta over sine squared theta, because that was my tangent. And then I flip it upside down like this. Okay. I'm going to stop right there for a moment just to see what's happening on the other side. Over here, I'm going to look at this as there's a cosine theta on the top. Secant I can turn into a 1 over cosine theta minus 1. So there's a reciprocal identity. This is a big fraction here. I'm going to have to shorten up here. So I'm going to multiply top and bottom on this one by the cosine theta. And I do that because I'm seeing this thing here, and rather than getting a common denominator, I'm just taking the denominator and multiplying top and bottom by it. So on the top, this times that, right, is just cosine squared theta. And on the bottom, there's a distributive property that this has to be multiplied by both of these things. So 1 over cosine theta times cosine theta. 1 over cosine theta, well, let me write it out. And then the 1 times cosine theta. Right. So what do I have now? I got a cosine squared theta on the top, and I've got a 1 minus the cosine theta on the bottom. All right, so on a button, what's happening? I'm comparing. I'm trying to show that this side equals that side. Well, I see the cosine squared on the top, but I got this thing that somehow needs to go away. I got a sine squared on the bottom. All right, so here's what I'm going to do. Sine squared theta. Remember my identity? I'm going to scroll back up here for a minute. Where was this identity? Sine squared theta plus cosine squared theta is 1. So that sine squared theta I can think of as 1 minus cosine squared theta. I'm going to do that right now. So what I have on the top, I'm going to leave this factored on the top. So I've got a cosine theta plus 1, and I've got a cosine squared theta up on top. The sine squared theta I'm going to rewrite as 1 minus the cosine squared theta. That's that Pythagorean identity in a slightly different form. The reason I like to do that here is because this is factorable. This is an a squared minus b squared. It's a difference of squares. I can factor that. I'm going to just rewrite the top down first here. I'm going to factor that into 1 and 1, cosine theta and cosine theta. Make one of them plus and one of them minus. Right? Notice if I multiply this back out, the 1 times 1 is the 1. The outside terms, the 1 times the plus cosine is cosine. The 1 times the minus cosine is minus cosine. So the outsides and the insides cancel out, and then you have a minus cosine squared, which is that. Okay. So indeed, it does factor that way. Whoops, I wanted an eraser there. But what happens now? I've got numerator and denominator factored, and there's a factor of 1 plus cosine theta here. There's a factor of 1 plus cosine theta there. They cancel out. What's left? What's left is a cosine squared theta on the top and a 1 minus cosine theta on the bottom. And oh my goodness, that's the same thing as there. So on this example, I didn't just turn one side into the other. I turned one side into something and the other side into the same something. And so if this is equal to that, and this is equal to that, then these two things must have been equal to start with. Okay, so there's 3 examples of some verifying trig identities. You'll have others to do in your homework, and we'll see these again and again as we work on bigger and better identities. So, thanks for watching.